Suppose we have to show that limit of x limit x tends to 2 square root of, let me take a tends to 2, square root of, you have a cube plus 3a square minus a plus 3 equals 3. Okay, so we start with the left hand side and we will solve it and show that whether it comes as equal to the right hand side. So my left hand side LHS is limit a tends to 2 square root of a cube plus 3a square minus a plus 3. This equals to, I can take this limit inside the square root. That means I can write square root of limit a tends to 2 a cube plus 3a square minus a plus 3, and obviously this is inside one bracket. This also we can write this way. This way also comes from the fundamental theorem. That means when you have square root or something like this, you can take this limit inside and take out the square root outside the limit. Next, you can break down the terms. You can write limit of the first term plus limit of the second term this way. So in one bracket you write limit a tends to 2 a cube plus limit a tends to 2 3a square minus limit a tends to 2 a plus limit a tends to 2 3. You have square root over whole thing. Then you replace the values. That means first in place of a you replace by 2, so you get 2 cube plus, here you have 3 into 2 square minus 2 plus 3. This is equal to square root of 2 to the 4, 4 to the 8 plus, here you have 2 to the 4 into 3, 4 3 the 12 minus 2 plus 3. You add up all the positive numbers. You have 8 plus 12 20 plus 3 is 23 minus 2 is 21. So you have square root of 21. Sorry, I think I have missed out something. Okay, so actually this will be square root of 3 into 7. You need to show this is root over 21, and you actually get that. And if actually it depends on whether it is a tends to 2 or whether it is a tends to minus 2. If it were a tends to minus 2, we would have got this expression limit of this function equals to 3. But when limit is a tends to 2, we will get this equal to square root of 21. And that's what we have got. So this part is proved. but we can always check this part in this bracket. matlab if you want to clarify the portion, that means if a tends to minus 2 were there, then what would have happened? Then here you would have got square root of minus 2 whole cube, then plus 3 into minus 2 square, then you have minus 2 plus 3, that is equals to square root of, this is minus 8, then you have plus 12 minus 2 plus 3. This is equals to square root of, you add up the positive sum terms, 12 plus 3 is 15, and then you have minus 2 terms, 8 plus 2 is 10. This was again minus 2, right? This will be minus 2. So this becomes minus minus plus, and you have 12 plus 2 plus 3. That means 12 plus 2 is 14, 14 plus 3 is 17, 14, 15, 16, 17, right? And you have minus 8. That will be square root of 17 minus 8 is 9, and that is equals to 3. So you see, if if the question was limit of a tends to minus 2, then in these expressions the values would be replaced by minus 2 and you would have got equals to 3. So both ways you have seen that if you keep on solving, you get the right hand side accordingly.